Hi kids, I decided to do a video today. If you have any questions at any point, please pause the video and ask me or Mr. Malovich if you need any help. We are happy to help, but we wanted you, because all of you will be in different places as far as slope, we wanted to go ahead and give you the opportunity to work at your own pace through this video because you all had a very different experience as far as Algebra 1. So we want to be able to find slope of lines, and we want to be able to identify whether lines are parallel and perpendicular. That's one of the biggest things in geometry about slope, is just that parallel and perpendicular idea. In the coordinate plane, the slope of a line is the ratio of the change along the y-axis and to the change along the x-axis. So it's the change in y over the change in x. We're looking at what happens here to here, rise, what happens vertically versus what happens horizontally. So the slope of a line containing 2 points with x1, y1, and x2, y2 is given by the formula y2 minus y1 over x2 minus x1. Remember, slope is rise over run. How much do you change up and down versus how much do you change left and right? When we look at graphs, what we want to do is we really want to concentrate, and I know yours isn't in color, we really want to concentrate on those points. When I'm looking at a graph, I'm just going to count the rise and the run. I'm not actually going to look at those points and do that. You can if you want to, but you are more than welcome to just count, especially when the graphs are just going by ones. So when I look at this slope, I know I go up 1, 2, 3, 4, 5. So I rise 5, so my slope is 5 over how much do I run? I'm running to the right, so going right is positive. 1, 2, 3, 4. So 5 over 4 is the slope. My slope is going up 5 and right 4. Up and right are both positive movements, so my slope is positive 5 over 4. I want you to go ahead and do part B and C and D, and then I'm going to come back, I'm going to pause the video and come back and talk about them. So go ahead and see if you can count the slope for all three. Okay, so in looking at part B, finding the slope, again we're counting. Notice that in this part it goes from this point L to this point M. When I counted, I went down, so I said that was down or negative 6. And then I went from there to the right. So right is a positive movement. So I got the slope of negative 6 over 3, which reduces to negative 2 over 1. 3 goes into 6 twice, 3 goes into 3 once, or just a slope of negative 2. I guess you can't see that. Let's move that over a little bit. So negative 2 over 1 or negative 2 is my slope. Most likely, if you're taking ACT, if you're taking any standardized test, you're going to see that as a slope of negative 2 and not negative 6 over 3 or negative 2 over 1. So go ahead and make sure that you reduce that. In part C, you'll notice that this is a horizontal line. It's a horizontal line, and if you notice in that horizontal line, remember slope is rise over run. And if you think about it, if I go from point N to point P, I don't rise at all. There's no rise, so my 0 is on top because there's no rise. But I do run to get from N to P. You can see I counted 1, 2, 3, 4, 5, 6, 7. You can see that I ran 7. So I use the slope of 0 over 7. 0 divided by any number is still 0. So a horizontal line has a slope of 0. In part D, notice that this is a vertical line. Vertical lines go up and down. In a vertical line, notice that my rise, I go from R to Q or Q to R. I move up and down. So there's an up and down movement of 5 there. 1, 2, 3, 4, 5. But it does not run at all. You cannot divide by 0. In math, we say that is undefined. So for a vertical line, the slope is undefined. Moving on to part E and finding the slope of a line, we're going to go back to the idea up here and use that formula of y minus y over x minus x. It says y2 minus y1 over x2 minus x1. It does not matter what point you call y x1, y1. and what point you call x2, y2. The point does not matter. I usually just go in order of the points on here when I subtract, so I end up having the first point is 0.2 and the second point is 0.1. So if you look, find the slope of the line containing this point 6, -2, so remember this is an xy, and the point -3, -5, so this is an xy. So if I'm finding the slope, I'm going to do y minus y, so y is -2 minus y, which is -5, over x, which is 6, and x here is -3. Keep in mind that we are subtracting. When I have minus a minus, if you remember minus a minus, you can just plug that into your calculator, or minus a minus, it's a plus. -2 plus 5 gives me 3. And then on the bottom, negative minus a minus here again, so 6 minus -3 is a plus. 6 plus 3 gives us 9. So my slope is 3 over 9, or simplifies to 1/3. Just to show you, if you flip-flopped that and you did the other points the other way around, and you said, okay, well, Mrs. Ward, it makes more sense to me. My teacher always told me I do this point first. That's fine. Do that point first. So I'm going to start with -5, and I'm going to subtract -2. And then I'm going to start with -3, and I'm going to subtract 6. Still keeping in mind that minus a minus is a plus. If I do -5 minus -2, -5 plus 2 is -3. And then -3 minus 6 is -9. A negative divided by a negative is still going to give us a positive. Notice those are the same, 1/3 and 1/3, so it does not matter which way you do it. Go ahead and look at part F. For part F, we have an xy point and an xy point. We're supposed to find the slope. So when I'm looking at that, I'm going to go ahead and say, okay, I'm going to subtract my y's. My y's are 2. Here's y. Here's a y. 2 minus -3 over my x's, 4, minus that x is 4 as well. Remember, minus a minus is a plus, so 2 plus 3 is 5. 4 minus 4 is 0, so what does that tell us? Well, remember, I can't divide by 0, so when I look at this, I know that the slope of this line is undefined. Moving on to the back. If you look at the top of the back, it gives you a summary of classifying slopes. And you want to make sure that whenever you classify slopes like you read. We always look at these from left to right. We read from left to right. We read graphs from left to right. When it's going uphill from left to right, that's a positive slope. Downhill is a negative slope. If it goes across in a horizontal, remember horizontal, that tells me there's a 0 slope, and the undefined slope is a vertical line. If you get confused between these two, the best thing to do is graph an example and see, what it is. You could pick 2 points on a vertical line and figure out, okay, is that undefined or is that 0? Because that seems to always be a sticking point where students seem to forget what's what. In the next part here, parallel lines, 2 non-vertical lines have the same slope. So if lines are parallel, they have the same slope. So they're parallel if they have the same slope, and if and only if they are parallel. Remember that all vertical lines are parallel and all horizontal lines are parallel. Perpendicular lines, remember perpendicular means that they make a right angle. 2 non-vertical lines are perpendicular if and only if slopes are what we call the opposite reciprocal. So what in the world does opposite mean? Opposite means change the sign. Change the sign. If it was positive, make it negative. If it was negative, make it positive. Reciprocal means you're going to flip it. So some examples of opposite reciprocals. If I have the slope of 3/4, the perpendicular slope, remember upside down t is perpendicular, because this is positive, the perpendicular would be negative. Because this is 3/4, it's going to be 4/3. So that is opposite reciprocals. Another example would be if we had, let's say m equals -2. Remember that whenever you have a whole number like that, or an integer like that, it's always over 1. So if my slope is -2, the perpendicular slope is going to be, because this was a negative, this is going to be positive. Instead of 2, it's going to be 1/2, or 1/2. Remember that vertical and horizontal lines are always perpendicular. Example number 2, it says determine whether line AB and line CD are parallel, so that means the same slope, perpendicular with the opposite reciprocal, or do they have neither? So I'm going to go ahead and find the slope of AB. When I look at AB, remember we have xy, xy. So AB, we're going to do 1 minus -5 over 1 minus -1. That slope gives me 6/2, because remember those both turn to positive, which is the slope of 3/1, or just 3. If I look at CD, line CD, the slope for CD, remember we have xy, xy. So the slope for CD is going to be 2 minus 1 over 3 minus 6. 2 minus 1 over 3 minus 6. 2 minus 1 is 1. 3 minus 6 is -3. When I look at these, if I look here is 3/1, this is -1/3, so these are perpendicular. I'm going to go ahead and pause this, do part B, and then come back and check your answer. Okay, you can see that I found the slope of AB to be 13/25. The slope of CD is 12. Because they're not the same and they're not opposite reciprocals, that means that they are neither parallel nor perpendicular. Let's look at the last set of examples. Example 3 says find the slope of a line that is parallel to CD, to line CD, and they tell us what C and D are. So I have to find parallel, but first I have to know the slope of CD. So when I look at CD, remember this is my xy, this is my xy. So I'm going to find the slope, -3 minus 0 over -2 minus 2. This up here gives me -3 minus 0 is -3. -2 minus 2 is -4, so it gives me a slope of +3/4. Because this tells us parallel, the slope of any line that is parallel to that is going to have a slope of 3/4. In the final example says that we want to find the slope of a line that is perpendicular to AD, and it gives us AD. So here's my xy for AD. If I'm going to find the slope of AD, I'm going to do my y minus y, 4 minus 0, over -3 minus 2. -3 minus 2. 4 minus 0 is 4. -3 minus 2 is -5. So the slope of AD, remember this is AD. We want to find the slope of any line that is perpendicular. Because it's perpendicular, the slope of the perpendicular line is going to be, because this is negative, that would be positive. Because this is 4/5, this is going to be 5/4. Do I have to have the positive? No, but it just reiterates or kind of enforces the idea that we know that. If you have any questions about this, please do not hesitate to ask, and go ahead and get your worksheet done. Have a great day.